Hello everyone, today we're going to talk about schema. Let us see the contents. Introduction, subschema, uses of schema and subschema, schema architecture, data independence and conclusion. Now let us see introduction to schema. The word schema comes from Greek word which means shape and all over structure, for more generally plan. Overall structure or design of database is called schema. In a broad sense, a schema is a mental framework or structure that helps individuals organize and interpret information. It is a cognitive structure that aids in understanding and processing new information based on pre-existing knowledge and experiences. A schema diagram, also known as an entity relationship diagram or database schema diagram, is a visual representation of the structure of a database. It illustrates the relationships and dependencies between different entities or tables in a database and helps in understanding the organization of data within the system. The primary components of a schema diagram includes entities, attributes and relationships. For example, let us see student schema. It contains name, roll number, class, marks, course number or department. Now let us see subschema. The subschema is a subset or proper subset of the schema and inherits the same property that a schema has. The plan or schema for a view is often called subschema. It gives the users a window through which he or she can view only that part of the database which is of interest to him or her, limiting their visibility to specific tables or data. Subschemas are often used for security and data isolation purposes. It's important to note that the term subschema may not have universally recognized or standardized meaning in all contexts. If you have a specific context or application in mind, providing additional details could help clarify the concept you are referring to. Now let us see uses of schema. Data organization. Schema provides a structured way to organize data within a database. They define the tables, fields, relationships and constraints, creating a blueprint for how data is stored and accessed. Data integrity. Now let us see data integrity. Schemas helps enforce data integrity by specifying rules and constraints. For example, a schema may define primary keys, foreign keys, and data types, ensuring that the data conforms to a predefined structure. Database design and development. During the design and development phase of database, schemas serve as a visual and conceptual guide. Designers use schema diagrams to plan and model the database structure before implementation. Security. Schema contribute to database security by allowing access control at the schema level. Different users or roles can be granted permissions to specify schemas, restricting access to certain parts of the database. Querying and reporting. Schemas play a crucial role in writing SQL queries and generating reports. They define the relationships between tables, helping users retrieve and analyze data effectively. Maintenance and evolution. Schemas facilitate database maintenance and evolution as our database requirements change over time. The schema can be modified and extended to accommodate new data elements or business rules. Documentation. Schemas serves as documentation for database structures. They provide a clear reference for developers, administrators, and other stakeholders to understand the organization of data within the database. Now let us see the uses of subschema. Data partitioning. Subschemas allow for data partitioning by defining subset of the overall schema. Different users or applications can work with their designated subschema, limiting their access to specific tables or views. Security and access control. Subschemas contribute to security and access control by restricting access to a portion of the database. Users or applications can be granted access only to the subschema that contains the relevant data for their operations. Isolation of data. Subschemas may isolate data, particularly in multi multi-tenant or multi-application environments, different entities can operate within their designated subschema without affecting or accessing data from other schemas. Customization for application. Application with specific data requirements can have their own subschema tailored to their needs. This allows for customization without affecting the overall database structure. Stability. In large-scale systems, subschemas can enhance scalability by allowing for the distribution of data across different segments. This can lead to more efficient data retrieval and improvement performance. Versioning. Subschemas can be used in versioning strategies where different versions of an application or service work with their designated subschemas. This allows for smooth transitions and backward compatibility during updates. Now let us see schema architecture. In this schema architecture, there are three levels. Schema architecture. The schema architecture consisting conceptual level, an external level, or an internal or physical level was first introduced by Charles Babbage in 1975. The motive of studying database architecture is to provide an abstract view, which means the system hides details on how the data is stored and maintained in database. Let us see the abstractions can be achieved by the help of three levels. First is physical level. It deals with how data is stored in storage medium. Physical level has physical internal or internal schema. Let us see logical level. It describes what data is stored in database and what relationship exists among those data. Logical level has logical or conceptual schema. Logical level hides the details of physical storage. Now let us see view level. This view level is closest to the user. It has external schema. External schema describe the part of the database that particular users group is interacting in and hides rest of the database from the user group. Now let us see the conclusion. In conclusion, database schema serves as the blueprint for organizing and structuring data within a database management system. It defines the logical and structural framework including tables, relationships, constraints, and attributes, ensuring data integrity and facilitating efficient retrieval. A well-designed schema is crucial for all-over performance, scalability, and maintainability of a database system. It provides a standardized way to present and recognize information, allowing for better management, analysis, and utilization of data resources. The careful consideration and design of the database schema are essential for building robust and effective database systems that meet the specific needs of applications and users.